Welcome to the DYNASET Beneath the Surface webinar, the solutions for Subsea. And my name is Janne Hietamäki, and I am the area sales manager for the North American market. Now, the webinar mostly will be focusing on the HPW pumps, since those are quite well and rapidly used in subsea applications. So that's kind of the main focus of the webinar. But yeah, let's move on. So what makes an HPW pump or an HPW pump a subsea pump? Fairly simple in the way that it has to be really corrosion resistant internally and externally. So the material choices made for these pumps are made in the sense that the pumps can handle seawater internally and externally. One of the things that is unique on the HPW pumps is that the leak detector hole also has threads in order to be able to collect the possible leakage coming from the pump into a bladder rather than letting it just run outside into the ocean. Okay, excuse me for a second, there's somebody coming still. Hello there. We've just started already, and I am recording this webinar, so just to let you know. But yeah, the subsea pump, that the baseline is a standard version HPW pump, which can handle pumping seawater and handle the seawater also externally. Now, what to be looking when choosing a pump for subsea use? Well, we at the factory, when providing information, would like to know a few things of the surroundings that they will be, like what is the needed performance of the pump, what are the available hydraulics, and what is the media that the pump will be pumping. Typically, the starting point would be seawater on that side, but still there might be some other medias that would be pumped through the HPW pump in the applications subsea. Basically, the question asked for the media would be to make sure that the seal compatibility will be okay with the media being pumped. Seawater, in that sense, that's always easy, but if there's something else that will be pumped with the pump, it's always good to check the seal compatibility on the point of doing the design for the application. The variants of the HPW pumps. Well, we do have available a data sheet that identifies the HPW subsea models that we currently have. And there is one thing that you really have to check on the standard versus the subsea pump is the fact that some of the pumps might have different pressure ratings between the standard version and the subsea version. For instance, the HPW 520, it is rated as a subsea version to 460 bar. Excuse me for a second, someone's coming in. Hello there. Welcome and join us. Just to let you know, we are recording the webinar, so that as an information. We just gone through a few slides on what makes a pump, a subsea version, that would be the corrosion resistance, and what we would like to know in the application design phase on the characteristics that the subsea pump would be in, so that we can make sure that the compatibility of the pump would be perfect for the application that it's used for. But yeah, on the variants of the subsea pumps, not all of our standard pumps have the equivalent version as a subsea version. So not all of the standard models are available in a subsea version, but quite many of them are actually. Now, as a single piston or as a single pump application, the typical place where we find these pumps would be like cavity blasters or pressure intensifiers in tool circuits. But here's kind of my question to you guys. I know quite a few of you have a lot of experience on the actual applications that go beneath the surface. So what have you come across in a single pump application? I'm sure cavity blaster, but is that actually the most commonly used application which carries a DYNASET pump? Do you have any insights that you would like to share?
Yeah, this is Chuck. Yeah, Cavity Blaster is the primary application that we're running on. We are running on some other tool circuits, but Cavity Blaster is the primary tool.
Okay. That's kind of what I have in my head, that the cavity blaster, that would be the most used application for a single DYNASET pump under the surface. Yeah. Thank you. Okay. But yeah, the options for first off, maintenance of the HPW pumps when first being deployed and used in an application and then taken back on the surface. This I cannot highlight enough, is the flushing with fresh water. That typically is something that for some reason tends to be forgotten. And excuse me, there's still someone in the lobby. I'll let them in. No, sorry about that. No one there. But anyways, yeah, the flushing of the pump, because naturally, if the pump has been running salt water, the salt will build up inside the pump if it's not thoroughly flushed. So you don't want to be having salt crystallizing in the internal parts of the pump, as that may cause into the jamming of the pump. And once it's back topside, also the drying of the pump, that would be a good idea. Just disconnect the water feeding line and let it run dry for a while. So it'll be dry, it'll be flushed, and yeah, everything is in good condition for taking the tool or the tool skid back to the warehouse. And on the maintenance side, when you get back to the storage, I'd recommend that do a visual inspection on the pump, that there is nothing awkward, no leakages. Then already once placing it back to the shelf in the storage, do the seal change and the water valve change. Once that's done, it's always in good operational condition for the next job it may have. And also once you take it apart for the seal change, You can also check the internals that there is nothing wrong inside, like the salt buildup or anything like that. And if possible, do a test run with it once you've maintained it, and it's good to be in the storage and good to go to the next job. Resources that we have for maintenance, naturally, the user manual, that'll provide quite a lot of information on the seal change, the water valve change, and all the maintenance intervals. And basically, it has all the needed information along with the spare parts sheet where you can actually see the blowout of the pump and see what's inside, and have all the necessary part numbers available so that the seal change and water valve change would be as easy as possible. Also, we have available some instructional videos on the seal change, and in the future, probably even more of the instruction videos for the maintenance side of things. Even possibly for the HPW 520 seal change, which I know Chuck is keen on having. So what are the specialties that can be done with the DYNASET pumps? Well, the parallel connection, that's always an option. Again, it's an easy way to increase the capacity of the tooling skid to have pumps in parallel and be more productive in that sense. Now, the pumps in the installation phase, they must have flow control valves on the hydraulic pressure port in order to basically prevent the situation where one pump would collect all the oil flow meant to go to all the three pumps, like in the case that on the small picture there are three HPW90s in series connection, and also the water output line would be good to equip with check valves in order for the water to go always on the right direction, not to actually be going towards the pump. Then there is the series connection. Now, in the series connection, you would basically connect the hydraulic tank or the pressure line, go through one pump straight to the other. Now, this will do the thing that you will double or have the full flow of the two pumps, but you will lower your output pressure. So the pressure that you get out would be basically the max pressure divided by the number of pumps that you have in a circuit like this. So an easy way to actually be increasing the volume of the media pumped, which you might require. Again, on the specialties, one other application that we have been designing stuff by ourselves would be the BOP intervention system. Now, if there's an ROV that has great hydraulics available, there would be available the HPW 360, which would, on the hydraulic side, require that 360 liters a minute at 250 bars. So a lot of hydraulics, 95 gallons at 3,600 PSI. And the output characteristics would be 220 liters a minute at 360 bar. So 58 gallons at 5,200 PSI. And that pump specifically has been designed for the BOP intervention system. Sorry about my tangling my tongue here. But anyways, that would be for an ROV that has great hydraulics available. Again, on the same side of things would be the sequence control for, in this case, those would be HPW 460s, which would be sequence controlled. Now, the graph shows the action, how the pump works, or the pump combination. You would have, in the starting point, you would have all 4 HPW pumps running and giving you that about 200 liters a minute of flow, but a low pressure. Now, since the BOP intervention system has those shears that cut down to the pipe, so when the shear or jaws, well, I'll use the term jaws. When the jaws move, they have great speed with high flow. And once they hit resistance and the water pressure or the output pressure of those pumps rises into a preset value, the sequence control would shut down one pump and basically be providing more pressure into the system so that the pressure increases, but naturally the movement of the jaw or the clamp that actually cuts the pipe would travel a little slower. Again, once the pressure rises, the second pump will stop and the remaining 2 continue. Again, the pressure rises and the speed naturally comes down, and the third pump will shut down just like the first ones, and yeah, it'll be slower but more powerful, and naturally back reverse. Now, that's basically one of our designs for the ROVs that have less hydraulics available, but still with a system like that, they can achieve the same job as the bigger ROVs that might be able to handle the thing with just that one single pump. Anyways, these are the BOP intervention systems seem to be applications where quite often there would be 2 types of different pumps for gaining that high volume with lower pressure and to have that fast movement of the actual tool doing the cutting. Now, in those situations, naturally you would be forced to be or forced to have good valving on both the water output lines and on the hydraulics line to prevent any kind of damage due to 2 different models of HPW pumps, so that the high pressure will not go to the lower pressure pump models and basically break them up in a situation where there might be the high pressure going to the wrong side of the lower pressure rating HPW pump. Now, again, I think there is quite a bit of manufacturers who have these kind of systems, and quite often I do see that they have DYNASET pumps on them. So I suppose this is, again, one of those widely used applications for DYNASET pumps. What about you guys? What are your experiences on the BOP side, or altogether on the multiple pump type of applications? Has anybody encountered something like that?
It's the same. set up on that on the BOPs as well.
Mm-hmm.
Typically a high-low system.
Mm-hmm. Yep, that's my impression too. What about other applications? Would it be always the BOP intervention, or is there something that is doing something completely different than what we experience to be the most common uses for our pumps? Well, moving on to the next one. Pressure intensification. This is one of those things that naturally on tolling circuits, I suppose, is quite often a demand for yeah, rising the pressure that is available from the ROV to the actual tooling circuit. Now the pressure HPI, hydraulic pressure intensifier, would do the job well. Yeah, the intensification ratio is 2.18, and the operating max pressure would be 350 bar. And again, a fairly simple installation and operation. The schematics on the picture, they show the operation. It's just basically having a control valve for the HPI unit, which would be turned on through that valve in the case of, or whenever needed. So this would be a good addition on the pressure intensification system. And again, still, it's the same patented or the same piston type system that the HPWs use. So the mechanics of the intensifier are reliable and again easy to maintain and robust. Now, all in all, the situations and applications that I've seen are pumps. Yeah, they are focusing on the cavity blasters and yeah, the BOP intervention system. So that's kind of the core of where we are at, or in the subsea market. And naturally, what are our cornerstones on the design of the subsea models of the pumps and applications is naturally the right materials and right understanding of the circumstances that the pumps would be working in, and to basically be improving the materials and the designs all the time to serve the industry better. Now, the webinar in itself was fairly short. Now, not a lot of ground to cover in that sense, but do you guys have any questions to our side?
Good morning, Janne. How are you? Afternoon to you.
Oh, morning. We're doing very good. How about you?
Sorry, this may have been answered, and I apologize. I was listening along while I was in transit somewhere.
Okay.
Is this not Photoshop? This presentation going to be shared somewhere so we could see those schematics and the details?
Yes.
I know you said it was going to be recorded, but I'm wondering if the actual.
It'll be recorded, and I've asked our marketing guys to actually be sharing the presentation with you guys so you can actually see what's on it. And naturally, all the information is available to you guys. So whatever you want, just let me know. And yeah, naturally, I'll provide the information. But like I said, yes, Yep. Also, the presentation will be shared with you guys, and yeah, the webinar itself, as it is recorded, it can be looked into at a later time.
Perfect. And then a little follow-up. Typically at Gensco, we sell individual pumps that then get incorporated into systems like some of the systems you detailed in the presentation.
Mm-hmm.
Does DYNASET actually construct or fabricate a combination system with all the valving and everything like some of those pictures, or is that all done in the aftermarket?
For instance, like the 460s that have the sequence control, that is something that we've constructed here. That's our own design in that sense. So yeah, we do some of those, and I think we have some projects that we have created and fabricated, like special units. They might be like in a single frame, 2 pistons or stuff like that. But yeah, we do some of those as projects. The sequence control, that was one of our own designs. So quite often it goes to the market like you guys, but we have the capability of doing some special projects naturally here.
Perfect. Thank you.
Thank you. Okay. What about any other questions? Okay. Well, I suppose I won't be keeping you any longer here. So thank you for attending, and please check the link for the feedback form, and please do fill that out. The actual link is also on the comment section or the chat window, so you can find it from there. And naturally, there will be on the presentation the link to the feedback. So please fill that out, and have a great day.